In example 13, we want to apply exactly the same ideas. We'll start off by completely factoring both the numerator and denominator. In this case, x minus 6 over x minus 6 cancels, so we can simplify this rational function to x plus 7 over x plus 5. This means in terms of finding vertical asymptotes, we take just that reduced denominator of x plus 5 set equal to 0, which gives us x equals negative 5 as a vertical asymptote. We also know that this has a multiplicity of 1, since we have that factor x plus 5 just being raised to the first power. We can also consider any horizontal or oblique asymptotes by considering our function g of x approaching x squared over x squared, which is equal to 1. Since all of our variables cancel out, that means that we have a horizontal asymptote occurring at y equals 1. I'm going to go ahead and just redraw that and not space things out so much. So I'm going to use that very first line as y equals 1. So we have our only horizontal asymptote, which means we have no oblique asymptote, and just a single vertical asymptote. From there, what we can do is look at filling in points. Our function is defined at 0, so we can plug in g of 0, which in this case would give us negative 42 over negative 30, or 7/5. Since we're sketching, really all that's important is to recognize that 7/5 is larger than 1. So our first point would be at x equals 0, and then y just slightly above our horizontal asymptote. We could also evaluate g of negative 4, a point close to our vertical asymptote, which would give us 3. So these 2 points start to define for us the shape of our curve. We know that we have this horizontal asymptote at y equals 1, so our function is going to be approaching closer and closer to that horizontal asymptote as x approaches positive infinity. And then we have to follow the pattern that these points are starting to show us. So our function has to be increasing as we approach that vertical asymptote from the left. Since the multiplicity for that asymptote is 1, we know that we're approaching from the opposite direction on the other side, and that our function is going to approach that horizontal asymptote from the other direction as well. So we can just, since we're simply sketching, fill in the shape of that curve on the opposite side there. One last thing to take note of would be what's happening to our function at x equals 6. If we look at the original function before we reduced, x minus 6 is part of the denominator, meaning our function is undefined at 6. So what we would actually want to do, if we want to sketch this or graph this more accurately, is put an open circle at that point. So that open circle would essentially act as a break so that our function, while it follows this curve, would get close to that point at x equals 6 and actually stop and then continue again on the other side of it. So different than a vertical asymptote, an open circle occurs at any point where our domain is restricted or where that point is outside of our domain, but we don't have a vertical asymptote.